Students, welcome to s.mathguru classes. Today we consider some problems. Last video it was given linear equation of second order with constant coefficient. Next we consider remaining problems. These are also easy, very simple. Solve d square minus 4d plus 13y equal to 0. We want to solve this problem. So d square, so directly we write auxiliary equation. This is m square minus 4m plus 13 equal to 0. In place of d we putting m and coefficient of y is 0. So this is unable to solve. We know if we are unable to solve, then we using the quadratic formula ax square plus bx plus c equal to 0. Then x equal to minus b plus minus b square minus 4ac by twice a. This we know this formula. So using this formula we get m equal to minus 4 plus minus 4 square minus 4 ac dividing by 2 into 1. This is 2. This is 4, this one 16 minus 52, this is 2, 4 plus minus 36, this one 2, 4 plus minus 6i. If we taking 2 common and cancel, then 2 plus minus 3i we get this one. Again you know this, if the roots are complex conjugate alpha plus minus I beta, then solution is y equal to e to the power alpha x a cos beta x plus b sin beta x. We know this. If the roots are complex conjugate alpha plus minus I beta, then alpha is real part e to the power real part x plus into a cos beta x b sin beta x. We know this. So this is real and this one imaginary. Therefore, the required solution is y equal to e to the power twice x a cos thrice x plus b sin thrice x, and this is our final answer. Very easy solution, very interesting problem. Solve d square minus n square y equal to 0. So d square already given. Now we consider auxiliary equation. Directly I want to write auxiliary equation. In place of d we write m minus n square equal to 0. So this is m square equal to n square, m equal to plus minus root over n square. So m equal to plus minus n. That means m equal to n and m equal to minus n. Therefore, the required solution is y equal to c1 e to the power minus nx c2 e to the power plus nx. Roots are unequal, minus n and plus n, these are unequal. So c1 e to the power minus nx, c2 e to the power nx. This is our answer. We consider this problem. Solve d square y dx square plus dy dx minus twice y equal to 0 when x equal to 0, y equal to 3 and dy dx equal to 0. That means we have to find particular solution. That means we have to find the values of constant also. After finding the constant, we get the particular solution and we have to write this equation. Now solution, this equation we can write this one given d square y dx square plus dy dx minus 2y equal to 0. Then this is d square plus d minus 2 into y equal to 0, where capital D means d dx and d square means d square by dx square. We get this. So d square dx square means capital D square, y taking from this y taking common, and d dx means d and minus 2. Now we want to write auxiliary equation. Auxiliary equation is m square plus m minus 2 equal to 0. Then this is m square plus twice m minus 2 equal to 0. M common from these two, m plus 2 minus 1 common, m plus 2 equal to 0, and m plus 2 into m minus 1, this equal to 0, m plus 2 equal to 0, m minus 1 equal to 0, so m equal to minus 2, m equal to 1. Therefore, the solution is, these are unequal, roots are unequal, solution is y equal to c1 e to the power minus twice x plus c2 e to the power x. Actually, this is our solution, but here some condition is given: x equal to 0, y equal to 3, dy dx equal to 0. That means we have to find the constant c1 and c2. So we differentiate, here given dy dx, so we differentiate this. Now dy dx c1 d dx of e to the power minus twice x, c2 d dx of e to the power x, dy dx c1 minus 2 e to the power minus twice x, or we can write in this way: e to the power minus twice x and d dx of minus twice x, c2 e to the power x, dy dx c1 e to the power minus twice x minus 2 into 1 plus c2 e to the power x. This is dy dx minus twice c1 e to the power minus twice x, c2 e to the power x. This is number 2 we consider. Now we consider the given condition. First, x equal to 0, y equal to 3. We consider 1. Since x equal to 0, y equal to 3. Now 1 implies, in equation number 1, putting y equal to 3 in equation 1, 3 equal to c1 e to the power 2 into 0, c2 e to the power 0. 3 c1 e to the power 0 means 1, e to the power 0 is 1. So we get 3 equal to c1 plus c2. Therefore, we get c1 plus c2 equal to 3, and this is number 3 we consider. Again, dy dx 0, x equal to 0, y equal to 3. Since x equal to 0, y equal to 3, and dy dx equal to 0, we putting this value in the equation number 2. Now 2 implies, in 2 dy dx we putting 0, minus twice c1 e to the power minus 2 into 0, c2 e to the power 0. This is 0, this is x equal to 0 and dy dx 0. So this implies minus 2 c1 into 1, c2 into 1. This is Taking this on left hand side, 2c1 minus c2 equal to 0. This is number 4 we get. Now we have to find the values of c1, c2. If we adding these two, then c2, c2 cancel. Now 3 plus 4 implies 3 plus 4, then we get in 3 c1 plus c2 and 4 2c1 minus c2, and on right hand side this is 3 and this is 0, and c2 c2 cancel, 3c1 equal to 3 and c1 equal to 1, we get 1. We putting the value of c1 in equation number 4. Now 4 implies in 4 2 into 1, 2 into 1 minus c2 equal to 0. So c2 taking this side, c2 equal to 2. Therefore what we get, c1 equal to 1, c2 equal to 2. We putting the values in equation number 1. Now 1 implies y equal to 1 into e to the power minus twice x, and c2 means 2 e to the power x. This is y equal to e to the power minus twice x, 2 e to the power x, and this is the required particular solution. Here the constants are absent. This solution is called particular solution. Particular solution means where constants are absent. We get the numerical value of this constant. So dear students, these are very interesting problem, very easy, very simple, whatever you can say. These are very interesting. So I hope you are all enjoying with me. If you are all enjoying, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.